Hi! Recently we posted a video on how to make water shader in Unity with shader graph. However, some of you wanted to see the same tutorial with Godot. So today I will be talking about how to make the same shader in Godot. This is how it will look like. This shader is suitable for some stylized graphics games. It has parallax effect and foam effect. If you are not interested in how to make this shader but want to achieve the same result, you can just follow the link in the description and get source files for free. To make water material, you need a shader. In Godot, anything in a project folder is a resource. So you need to create a certain type of resource, which is called visual shader. There are other types of shaders, but they are not that easy to use. In visual shaders, you can just connect a bunch of nodes and see the result. That way you can focus on achieving certain effects without knowing the depths of computer graphics. To open a shader, just double click on it. Normally it will pop up in bottom window. To make your life more comfortable, I will open this window into full screen mode. This window looks more like Blender shaders. However, there are some differences. There are different shader types. There is vertex and fragment shader. You can switch between them in the top left corner. Today we will be using both of them, so please pay attention in which mode we are working. To navigate the window itself, you need to use your mouse. With left mouse button, you can select different nodes and make a group selection. Use your right mouse button to create new nodes. You can search them in the menu or just type the name. To create material from shader, you just need to create a resource of type shader material and put visual shader into specific field. So that's it for controls. They should be enough to replicate all of the things I did in my shader. So let's move to water effect explanation. We will start with vertex shader. Unlike Unity, Godot doesn't provide us with world space position of a pixel in fragment shader. That means that the only way to get it is to pass it manually through the vertex shader. There are not many vector3 values in the outputs here, and you cannot add new outputs to this list. That's why I decided to occupy color output and use it to store the position. Colors and vectors are the same things in shader. They are both represented as a number of floating point values. To get vertex world space position, I need to transform it from local space to world space. This is done with transform vector mult node. As the first argument, I pass model transform matrix, and as a second I pass the position in object space, so in local space. As a result of this transformation, I get another vector3, which is world space position of my vertex. I plug it into color that I use as an output for position, and on that place our vertex shader is over. Let's move to pixel shader. It is also named fragment shader, depending on the API that you are using. In vertex shader you can move vertices and store some data about them, and in fragment shader you are able to draw on screen. We write a program which describes how a certain pixel should be colored. Because of this output, put it into color, we now can access world space position in fragment shader. I split this whole section into 3 parts. You can see them inside of big black group nodes. The first one will make parallax effect, second one will add some foam on borders, and the third one will make surface foam with caustic texture. We will talk individually about each of them. Let's start with the simplest one, which is the foam effect on the surface. We have this caustic texture, but we need to get mask on the surface. To do this, we need to sample it with some UV coordinates. In our case, we don't want to make this texture be dependent on the scale of the object, so we will be sampling it in world space. Let's get our color input, which is not color as you remember, it is just the value that we transferred from vertex shader and it was interpolated across multiple vertices. So now it just represents some world space position of this pixel. We just combine X and Z components of this vector, then we multiply it by tiling to scale it properly. I use one usual version and one inverted. We are doing more complex animation and are using 2 textures that are scrolling, so we don't want them to be repeated at any particular moment. That's why we flip another texture. Then we add some offset, but if we just use constant offset it wouldn't be animated. So we multiply time by some speed value and use it as offset. Then we take the maximum value of these 2 samples, so we are just picking up the greatest value of both. Then we use smooth step to change the gradient behavior. We cut off some too dark areas and some too bright areas as well. With that we finally achieve our mask to blend 2 colors. We are blending them with mix node. As I put base color, and as B I use foam color. And we should put mask into weight parameter. If we go and check the results in editor, you can see that two textures are already scrolling and creating some nice animation. When we add any parameters in the shader, they appear in the material, and you can easily change them. Next block is parallax effect. Let's go and see what is there. Basically, parallax effect is just intersection of a ray with a plane, so we just mathematically add another plane under the surface. To calculate intersection of ray and the plane, you can use this formula. You can see that when we calculate point with this formula, we get the mid of plane and a line. I took world space position from color node. Remember that we packed position into color in vertex shader. And then I used another node which actually does this plane ray intersection. This is a custom node. You can create it and write some function in shading language there. It is really useful to keep things compact and nice. As an input, I will plug my origin and ray direction. Origin is the position of the fragment and direction is camera position minus position of the fragment. We could normalize the direction, but it's not that necessary because our formula handles that. When we got the midpoint of the ray and the plane, we use it as an input for UV coordinates. Same as we did with foam mask, we use x and z values as x and y respectively. Then I multiply by tiling and add offset. These values of tiling and speed that is multiplied by time when we get offset are different from the ones that we used for surface mask. This is to add more variety to the effect. After we sample two textures with given UV coordinates, we are combining them with multiplication. Now we use result as a source for mix. Parameter A will be some shallow color and parameter B will be some deep color. Let's see what it does. When we move the camera, this bottom plane stays in the same place and it is adding some depth to our water. Let's try to combine it with foam. To do this, we just need to replace shallow color in mix. We should use the result of our parallax effect in here. Now the effect looks a lot better with these two layers. We can definitely see that there is layer on top in the surface of the water and one in the bottom. But that's not everything. I have the last part, which is the smallest one, but adds some more natural look to our water. When we see some objects in the water, we want to see a small outline of fade that will represent foam around the object. To make such an effect, we need to sample a depth texture, get position in world space from this depth. This is done with special Godot node, and then we will calculate the distance between our fragment position and this depth position. This way we calculated the actual depth of something in our water from the surface. Then we use smooth step. I will remind you that we use it to make gradient look differently, change the linear function to something else, and then we need to invert the result and blend it with foam mask by using max operator. Now when we go to the editor, you see that a small outline is around all of the objects in the water. On that note, I would say that our water is complete. Here is how the final effect looks like. I will remind you that source files for this water shader are provided in the link in the description. If you weren't able to replicate the same graph, you can go there and download and see what you did wrong, or maybe just even use the end result. So that's it. I hope you enjoyed this video. Please tell us if you want more videos on Godot shader topic, like this video and subscribe to our channel. And see you next time!